Hello everyone, welcome to Payment Tech Video. This is another example of IPv4 Class C subnetting. So depending on what type of question they ask, so let's go ahead and take a look. So this time they gave us IP address and they said this IP address belongs to what network. So the IP address they gave us 192.168.5.118 with the CIDR notation of 26. And they said this IP address belongs to what network. So the first step, by just looking at the IP address, this is Class C IP address. How do we know? Looking at the first octet, 192 falls into Class C range. So Class C, this is 192, and the default subnet mask for Class C is 255.255.255.0. That's a default subnet mask. But here, 26, we know that's not a default subnet mask, because when we have 255.255.255.0, that means we have 24 ones, not 26 ones. Let me show you. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16. 1, 2, 3, 4, 5, 6, 7, 8. That's 24. That's a default subnet mask. So this is a default subnet mask for Class C, but this is 26. It means we have 24, 25, 26. So basically these two added. So our original code line, default subnet mask for Class C, it's here, 255.255.255.0. right? Converting this binary to decimal gives us 255.255.255.0. But with the 26, when we count left to right, 26 ones, these are representing the network bits, and zeros representing the host bits. So if we draw a line between all the ones and zeros, so here is our cut line for our subnet. Therefore, all these ones, that's network bits, network bits, network bits, our subnet bits, and these zeros our host bits. So again, what was the first step? Simply looking at the IP address, the first octet 192, and then determining what class this is. This is Class C. And then looking at this CIDR notation of the subnet mask. In this case, 26. It means 26 bits turned on. So here if we count, going from left to right, 8 plus 8, 16 plus 8, 24, 25, 26. So again, yes, the default subnet mask, the cut line was here. And as you can see, now the cut line moved here 2 bits to the right. This is known as subnetting. So anytime the cut line moves to the right, it's subnetting, breaking a large network into the smaller network. So we will have multiple other subnets, and each subnet has less number of hosts. Okay, and then here, the zeros, it's pretty much for the host bits. Then what is the next step? Next step, we have to look at the last bit that is turned on. In this case, this is the last bit turned on. What is the decimal value for the last bit? So the decimal value for the last bit is 64. This is known as network increment or block ID. On what octet? On the last octet. So our network address is incrementing by 64 on the last octet. Okay, let me show you how. Well, you guys remember earlier I talked about this is Class C, looking at the first octet. So we have to write down the zero network. So what is the zero network for the Class C? Basically, we just need to write the entire network portion. And for the host portion, we have to put 0. Okay, so the network portion would be 192.168.5.0. This is the host portion, and that's the network portion. Because 192 Class C, and Class C is 255.255.255.0, right? Therefore, we can see here is the network portion, and to this side is the host information. Okay, now what would be the next subnet? Well, we have to increment by 64. The last bit turned on, decimal value, that's our network increment, right? On the last octet here, as we can see, we are working on the last octet, right? So the last octet is this one. Let's increment by 64 on the last octet, 192.168.5.64. And the next one, 192, 168.5.64 plus 64, 128. And if we continue incrementing, 192.168.5, 128 plus 64, 192. And if we continue incrementing, 192.168.5.192 plus 64 is 256. So here, as you can see, I'm writing with different color. 256 not valid IP address. So here we can see we have 4 different subnets. And earlier we talked about the number of subnets. It's pretty much 2 to the power of subnet bits. And in this case, we have 2 subnet bits, 2 to the power of 2, which is 4. Or we can count at the bottom going from left to right, starting with number 2, 2, 4. So that's how many subnets we can have. And the number of hosts, we can count right to left, starting with 2, 4, 8, 16, 32, 64, minus 2, 62. So we will have 62 available IP addresses per subnet. We will have 4 subnets, each subnet 62 available IP addresses. Let's talk about this formula. The number of hosts, we have 2 to the power of host minus 2. So 2, how many host bits? 1, 2, 3, 4, 5, 6 host bits. So 2 to the power of host bits minus 2. And we have 6 host bits. Zeros representing the host bits. 2 to the power of 6 minus 2, which is 64 minus 2, and it is 62. So again, we can use this method going from left to right, starting with number 2 at the bottom to 4, and this is the number of subnets. And then from here, going from right to left for the number of hosts, starting with 2, 2, 4, 8, 16, 32, 64, and always minus 2 to get the available IP addresses. So we get 62. And again, we do the minus 2 because of the network address and the broadcast address. We cannot use them to assign to the computers or network devices. They are reserved, basically, reserved for the network address and the broadcast address, which is used by routers, routing protocols, applications, all that. So here we will have, again, 4 subnets, each subnet with 62 available IP addresses when we talk about the CIDR notation of 26. And what is this CIDR notation 26? If you want to write down in subnet mask, the full subnet mask version. So it is basically the first octet, all bits turned on. So that's 8 bits. In the first octet, that's 255. The second bit, all the 8 bits turned on. That's another 255. The third bit, all the bits turned on. That's another 255. And on the last octet here, we can see only 2 bits turned on, right? So when we count 26, so 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, 25, 26. So on the last octet, we have only 2 bits turned on. So if we convert this binary to decimal, which again, my previous videos, make sure you watch if you haven't watched. I talked about how we can convert binary to decimal to binary, all that, number system conversions. So here we have only 2 bits turned on. And what is the decimal value? 128, 64. So we just need to add the decimal values of the ones that are already being turned on. In this case, this one turned on, this one turned on. The rest of them turned off. So 128 plus 64, that's 192. So this is our new subnet mask for the CIDR notation of 26. Okay, now let's take a look and see this IP address with this subnet mask or this CIDR notation falls into which subnetwork. So these are the 4 subnetwork. And let's erase to make some space. So we talked about that's not the valid one. So what we need to do, we have to look at the host portion. In this case, 118, that's for the host. And 192.168.5, that's for the network. So looking at 118, the last octet, and you see we were incrementing on the last octet, right? So we have to pay attention here for the last octet and then see this IP address, this number falls into which one. So this subnet 0 and the next one is 64. So 118, it's not in this one. 64 to 128. So 118 falls in between 64 and 128. Therefore, it is in this one. So let's write down the broadcast. If this is the network address here, the broadcast address for this network address would be one less than the next subnetwork address, right? Always broadcast address is one less than the next subnetwork. So the easiest way to find the broadcast address, it's basically by keep incrementing. So here we can see we were incrementing by 64 on the last octet because we are on the last octet, the cut line here, right? So 64 plus 64, 128. So here, this is our next subnetwork. One less than 128 would be 127, right? So that's the broadcast address, 192.168.5.127. And then here we have all these IP addresses in between. These are the usable IP addresses, all the available IP addresses that we can assign to the network devices on the network. So here the first usable IP address is just one IP address after this one. Therefore would be 192.168.5.65 because .64, that's this network address. .65 is the first available IP address. 2, it goes to 192.168.5.1 less than broadcast 126. So these are the available IP addresses for this subnet. And looking at this IP address, 192.168.5.118, it will fall in between these IP addresses, between the 5.65 to 5.126, which is kind of closer to the end, the 126. So if we had these type of questions that they gave us the IP address with the CIDR notation, and they asked what is the network address or what would be the network increment. So the network increment is 64. The network address is 192.168.5.64. The first available IP address is this. The last available IP address is this. And the broadcast address is this for this IP address. And the subnet mask is 255.255.255.192. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.